Welcome, everybody, to the Channel Vision Magazine webinar featuring Packet Fabric, which is going to share with you how next generation Interconnect enables an agile, hybrid, and multi-cloud core. I'm your moderator, Bruce Christian, Senior Editor of Channel Vision Magazine. Our guests are Packet Fabric's Chief Marketing Officer, Alex Hinthorn-Iwani, and Content Manager, Kessia Lawson-Shanks. Welcome to you both. With that, let me turn it over to Alex.
Thanks a lot. Appreciate it. And thanks everyone for joining us today. Pleasure to be here and really delighted that we can take you through some material that hopefully will be really educational for you and useful in building your business or building your IT stack or your offerings. So the way that we're going to kind of go today is really talk first at a high level, and starting with this point about the state of digital business today. I'm going to take you through the rationale for why there's a need for agile connectivity. And we're going to go through some of that material, and then Kessia is going to actually take us through a demo of Packet Fabric's services and capabilities. So you get a feel for what next-gen agile interconnection really looks like. But let's start with this slide, which is that digital business is all business now, right? You don't really have the option to be a digital business anymore in a way. And what that means is that agility is really important, the ability to react fast, to move fast, to get to market fast, to respond to changes in all sorts of different demands. Not just, you can think about that from a customer point of view, but also from an internal point of view. All of the expectations for how services and applications work have been consumerized. And the way that enterprises are building their digital applications and services is on a cloud infrastructure basis. So cloud provides that infrastructure agility, the ability to get it fast, to consume it, to scale it up and scale it down. And as a result, this is just one of the many statistics on this from Gartner. 93% of enterprises have a hybrid multi-cloud strategy. And there's lots of other great studies on this. There was a survey from HashiCorp that said 76% of enterprises are already multi-cloud. And and that within a couple of years, 90% will be multi-cloud in some fashion. I love this quote from a Gartner distinguished analyst that says, we're not planning for one future, we need to plan for many possible futures. That's just indicative of how fast things change in a digital business environment. So, if we think about why hybrid and multi-cloud in particular, why all of this is expanding in complexity in terms of the infrastructure being used. It's not just, you used to have just a single data center or maybe a primary and a backup. Now you have multiple cloud providers, multiple co-location data centers. And what's driving that? One is that there are diverse application requirements. So think about it as, for example, in a multi-cloud setting, you might have one group that's really developing all the new digital applications in, AWS, for example, but you might have, .NET applications or, office applications sitting in a data center, and then they're starting to move to Azure, or you have a Microsoft AD going to Azure AD. So that's a great example of a multi-cloud as well as a hybrid type of scenario. Or let's say, you have Oracle Cloud, because you're moving your, data management and HR information systems to cloud that way. And again, a lot of those things stay hybrid. There are a lot of pieces that stay in the private cloud data center, because there may be sensitive or legacy components that really just can't move effectively. There's also a classic scenario that happens, and we see this all the time, of organizations going through mergers or acquisitions where there are distinct application infrastructure stacks, different co-location data centers, different cloud providers, and they all have to come together. There's also things like regulatory requirements where you may be required to have different infrastructures to avoid concentration risks, such as in payment processing, where issuer versus merchant processing has to happen in different data centers or clouds. There's also really interesting sort of changes in how hosting impacts economics, like where you host or where your data lives may matter from a point of view of regulations, from a point of view of taxation, things like that. And organizations that are doing lots of online business start to pay attention to those things. Furthermore, there's just simply vendor diversification, risk management, the need to have multiple providers, to not just be reliant on one vendor, one brand, has always been a smart strategy. And that holds the same in the hybrid and multi-cloud arena. Finally, backup and recovery are by nature diverse. And so you might have your primary data centers in one, in a certain co-location provider. You may have cloud providers, but you may be using a managed service oriented provider like a Phoenix Snap or something like that, or a specialist like WebAir or Opti9 to do backup or disaster recovery as a service. So there's lots and lots of proliferating hybrid and multi-cloud elements that are driving the need for this kind of expanding architecture. And what that means then for the network is that it's really important to have agility all across that infrastructure. And that includes being able to move mission critical workflows and data movement between those components. So if you think about the modern enterprise WAN, it's sort of split into two major segments or two domains. At the bottom of this diagram is you have your sort of the way that users access the application or service edge of the infrastructure. So for example, if you're in offices or in home offices, you might be using SD-WAN tunnels or some other way to get to your kind of services and applications. You may be using SASE, secure access service edge services to get home users or remote users there. If you're dealing with consumers or partners of the business coming across the internet, then that's an internet edge going to a CDN or other things like that. And that may also include 5G or mobile edge use cases of getting access to those applications and services. But inside the core of the infrastructure, that's where you have those co-location data centers, your public cloud providers, your enterprise SaaS like Salesforce, et cetera, and even independent cloud providers increasingly that are part of how an enterprise builds, hosts, and delivers all these applications. And of course, there's many other elements depending on what kind of, if you have a consumer-facing element, you might have internet exchange providers you need to connect to. You have CDNs, you have clean pipe services to protect your consumer or internet-based traffic and keep it clean, like Magic Transit by Cloudflare, things like that. So there's all sorts of things that plug into this core, and you need to be able to move traffic in an agile fashion. Why? Because that core set of infrastructure has to meet a number of different types of demands over time. So there's, for example, steady state. We all think of networks oftentimes as pretty static in the sense that, okay, you have these high-speed links, and over time they steadily increase in terms of the demand placed on them. But the reality is there is and always has been seasonality in many businesses, not just in your classic travel or other kind of businesses that experience seasonality, but could be tax season, could be just end of quarter season for the business. There's all sorts of different demands placed on it. But also increasingly, there's more innovation, more need to drive analytics, AI, things like that, that are causing demands to shift across that infrastructure. Because let's say if you need to move a bunch of data for an analytics project, that's going to place a lot of demand on certain network connections between these infrastructure pieces that isn't normal. It just, so it can be, kind of like slightly unpredictable that way it's planned, but it's not like you had it in a 3-year plan. It's something that comes up next quarter or any new initiative. Finally, there's just disruption, things that you don't expect to happen, new, rapid response to market, or a spike in demand somewhere in the world, for your services or that sort of thing, geographical changes, all those sorts of things. We live in a fairly unpredictable time, and because digital business tends to shift so much, it can create unpredictable demand changes in terms of how you need to move traffic across that core. So that's why agility is just so very important. Now, the problem in terms of how you've connected these core elements together, and that's a focus today, is this cloud core, is that you typically had two, maybe three sort of choices in terms of interconnection. One is traditional telco. The great thing about traditional telco services is that they're secure, they're private, you get an SLA, so there's predictable performance. But agility is not exactly the term you think of when you think of traditional telecom. It can take weeks to get a quote in some cases, right? And it can take months to provision services. And furthermore, you oftentimes have to commit long-term, multi-year contracts to get any reasonable price. But in a world where things shift and change, just think about it, the fact that if you have to contract today for the peak capacity demands of 3 years from now, and let's just say they're going up 25% a year, you're automatically stranding a lot of capacity over time. You're not really using it effectively. Furthermore, what if that particular connection becomes less relevant because of shifts in the sort of demand footprint across your infrastructure? Well, too bad. You're stuck with that contract and you're just burning that bandwidth and that money along with it. So it can create a lot of waste, both in terms of wasted opportunities if you can't move in time to meet a market need or a business need, and waste because that long-term inflexible way of doing business is just unwieldy. It doesn't give you agility. One of the analogies I thought of recently was that the way that traditional telecom services are contracted and procured, especially when you think of a multi-year, is sort of like building an office building. I mean, it takes, it's a little bit, an exaggeration, but it takes a long time to contract, and then you're kind of stuck in this 3-year process. It's not really a digital world sort of way of consuming things, certainly not cloud-like. Now, another option is internet, but it faces severe limitations. One, it's not secure, it's not private, it's not predictable. There is no SLA for the internet. So there's a lot of risk built into it. And frankly, it just can't scale very high. So oftentimes, the need to connect, these core pieces together, some of them, you might use some internet connection, but let's be realistic. It's not a scalable or high performance kind of answer. It's not carrier class. Now, there are some provider-specific interconnection answers, say from some co-location providers. The only problem with that is that if you go that route, you're kind of stuck with that provider. It doesn't give you freedom of movement. It creates a lot of barriers in terms of your choices, in terms of where you host and et cetera. And at the end of the day, the most important thing for your infrastructure is to deliver great user experiences. So you want to be able to have lots and lots of choice. So these are kind of limiting factors in terms of how agile your interconnection can be. And at the end of the day, the digital business is the business. It's way too important to leave to kind of these legacy technology and business models. And that's really where this notion of a network as a service, which is what we provide, comes in. And a way to think about this is that interconnection and connectivity for that cloud core has become itself a cloud service. And this is the state of the art. So the idea for Packet Fabric in particular was that we wanted to create something that was basically telco or carrier class and quality and scale, massively scalable, but that was completely on demand and consumable, like you think of that about the cloud. Like you never think, well, if I go to AWS, can I get this number of servers? You pretty much know that you can get that many servers, right? And the same thing with our approaches. You should be able to know, like, hey, if we have a need for hundreds of gigabits of bandwidth from here and there, we can get it. It's there. It's any to any, kind of like the internet, in the sense that's why it's sort of a fabric, right? It's not just you're pinning up particular links, and that there's a very limited sense of that. But the ability to say, I have freedom to create a network topology that really fits my business very, very quickly and flexibly. And the consumption model is very cloud-like. You can think of it as sort of like a telco that's built as a software as a service. It has a portal, programmable API. You're going to see the portal here in a bit when Kezia takes us through a demo. It's very flexible bandwidth deployment. In fact, I mean, I think we're going to show some aspects of being able to have monthly data center interconnect and actually burst. So you'll see some really interesting things that I think are kind of eye-opening in terms of what you can do. And because we built at scale, it's meant to provide a very, not just predictable service, but a predictable kind of pricing environment as well. So it's very easy to, kind of know that there's certain, that this is very predictably affordable in all sorts of configurations, competitive with any other sort of service offering that you would think of. So we've built a huge network platform. It's a private optical backbone. We have our own, we have hundreds of POPs and co-location data centers, multiple availability zones, so resiliency built in, different, separate hardware stacks. It's a 50 terabit plus backbone. That is a huge backbone. So we have lots and lots of, kind of hardware stack and path redundancy. Is totally automated. You'll see some of that. And really oriented towards being an ecosystem to be able to reach all sorts of different providers and plug in lots of value into this fabric. And we have a ton of expertise that we alongside our partners really use to help customers succeed. And, all those things come together to create a really high NPS, just extremely delighted customers that grow with us steadily and pretty much predictably. Customers tend to come on board with us and then just grow because they're just delighted with what they experience in terms of the service. So just real quickly before I hand off for demo, we offer a variety of different services. We won't show you all of them. We'll give you a little bit of a teaser today of a couple of these things. We have point-to-point connectivity. This is Ethernet private line. It's kind of, you can think of it as like a pseudo-wire service. It is a turnkey connection, of 2 ports and 2 different co-location data centers where we have POPs and, and a kind of a backbone link between them. This is sort of a turnkey concept. And you can think of this as a great alternative to having redundant waves because it's naturally resilient in terms of paths. We also have hybrid cloud connectivity, be able to connect from co-location data centers to a variety of different cloud providers. So AWS, Azure, GCP, IBM, Oracle, Salesforce, WebEx, et cetera, et cetera. And we also have what we call the cloud router. Cloud router, you can think of as a massively scalable, a BGP capable router as a service. So if you're trying to connect together multiple regions in a cloud provider or go across multiple cloud provider regions, from AWS, GCP, et cetera, and even plug in co-location data centers, et cetera, it acts as sort of like the router for all that connectivity. So it simplifies all of the, kind of the very complex networking that can arise if you're connecting multiple cloud providers together. It also provides a scalable, low latency kind of routing way to deliver all that traffic without kind of hairpinning through single points of computing or support for the routing architecture. Finally, there's a kind of a custom option, which is you can get ports, you can get, many, many different virtual circuits. You can configure them all the way that you want across our network, our global network footprint. So that's kind of a quick overview of Packet Fabric. And with that, I'm going to invite Kez to kind of show you a little bit of what this looks like and feels like in terms of the service.
Perfect. Well, thank you, Alex. So as you can see, this is our portal, and I'm going to be showing 2 main aspects of our connectivity that you can get on demand via the Packet Fabric service. First, I'm going to show you how to build a high-speed connection between 2 data centers, and I'm going to highlight the capability that allows you to consume bandwidth on an hourly billing and bursting basis. And you're going to see how easy it is to set up. I've already, for this demo, created 2 interfaces. one at Phoenix Snap and one at Santa Clara, both 10 gigs. So that's already in place. What I'm going to do right now is show you how to build a long haul connection. So you want to click on the virtual circuit in here and choose backbone. You're going to see both the ports I've created before, and we're just going to choose one of each. And then we're going to scroll down to the pricing plan. You can change who you bill to if that's necessary, but these are our pricing options. We have long haul dedicated, and then we have long haul usage base, which basically means you pay for the amount you use, and then long haul hourly, which is you just get billed on an hourly basis. For this demo, I'm going to choose the long haul dedicated. And then I'm going to choose month to month, but we do go up to 36 months. And again, since I am in the portal, we don't have a sandbox. This is all live. So I want to make sure it's month to month. And then we offer 50 megs up to 100 gigs. But since these are only 10 gig ports, I can go up to 10 gigs. But for the sake of this demo, I'm going to just choose one.
So this is happening on our production network live right now. This is not just like some sandbox software demo, canned demo.
No, this is live, and I'm pretty sure
we're building a real connection right now.
Yes, and the reason why I choose 1 gig and month to month is because I don't want my billing team to come after me if I do higher or for longer. So this is where you can name your virtual circuit whatever you like. You can also choose your own VLANs if you like. And then now you can see it's 400 gigs for the price. And
or $400 rather.
Yeah, sorry, $400. And for 1 gig on a month, and then it's going to be created.
And the thing that's really kind of I remember when I first saw this, it's sort of like, you know, you think of these kind of interconnection things as being so cumbersome, you know, and obviously there is a cross connect and there's some other things involved, but in terms of actually provisioning a network, I mean, it's done.
Yeah, it's live. So now we have a backbone between Phoenix and San Francisco. So I'm just going to click on this and I'm going to go to more details, but you do get a little quick overview of what we've just built out right here. And this is kind of more in-depth view of our portal of what you have just built out. What I'm going to show you now is how to burst this. Since we chose 1 gig, we do have the option to go up to 9 more gigs, but here
and just as you're doing that, Kaz, I was just going to want to just point out again that this is between 2 different co-location providers. So we span a lot of different co-location providers in our network. Just emphasize that.
So here I'm going to just go up to 1 more gig and you can see, oh, here we go. Sorry. So I'm just going to go up, build 1 more gig. So then we have 2 gigs and it's going to be 80 cents per hour. So then I'm just going to start the burst. And it's just going to take a second to update.
So one of the things I want to point out about that pricing is, I mean, 80 cents per hour for a gig is indicates that the crossover between an hourly and a monthly is not punitively short. You know, one of the fears you can have about something like an hourly service option is that you basically reach a month level of billing in a day or something like that. You can tell based on, it's like $400 a month for 1 gig, 80 cents. It does take you a number of days to cross over. So it is really meant for real use. It's not just a gimmick. It's priced, you know, to make it really useful.
Yeah, if you ever need a burst, it's super handy. And now you can see it's already in place and we have an additional gig for bursting. And whenever you want to delete it, you can just go up to the burst button and you can either upgrade or delete. I'm going to just delete it and then you just type in delete. and then it will remove in a few moments, and then you won't have a burst anymore, and you'll just be back to month-to-month billing. But now I've just showed you how to create a virtual circuit on our portal. I'm going to actually switch over to our cloud router that Alex mentioned earlier, which is very.
So that's a data center interconnect sort of a use case. And just as you're switching over, go ahead, Kes, just to note that one of the, think about the kinds of things you can do with that bursting, that flexible bursting, and all this can be done via API as well, is that, let's say, for example, you've backup and restore sort of operations. Well, when you seed a backup, you might need to burst bandwidth to be able to move that data quickly, right? But when you're doing just those kind of incremental backup cycles after that, after your initial seeding, that's doesn't need as much. And yeah, you might need to burst, but not nearly as much. If you need to restore, again, you can burst up high. So let's say, for example, if your normal kind of bandwidth demand between two data centers was 5 gigs or something like that, or whatever it is, you could have that as your baseline. You could burst up to the 10 gigs, or if you had 100 gig ports, you can burst all the way up such that you can move that data back and forth really fast as needed. And so that's, there's a lot of things you can think about that are become possible with that bursting capability. And it is pretty much a unique thing to be able to burst hourly on that kind of connection. So back to you on Cloud Router.
No worries. Thank you for that. So for this Cloud Router video, it's going to be fairly in-depth demo. We're going to connect multiple cloud providers, but the point is showing how easy it is to build a vendor-neutral cloud architecture. In fact, it can really happen in the span of minutes. But first, I want to kind of explain a little bit further than Alex did earlier on the Cloud Router. Cloud Router provides connectivity between cloud providers without requiring you to have a data center or any physical networking at all. It works as a distributed virtual routing service that is completely hosted on our network as a service platform. So let me just start this. And it is pre-recorded as well. But the topology we're going to build involves 4 cloud service providers, each with their own internal subnet that will be routed. To start, you're going to want to log into your Packet Fabric portal, create a cloud router, give the cloud router a name, choose your billing department if you need to, and then you're going to want to place your order. From there, looking at our topology, it's time to add a connection, and we're going to add AWS first. I just want to add that our Cloud Router documentation in the knowledge base on our website, you have the steps related not only to the Packet Fabric side, but the AWS side or any other cloud service provider side. And all of this information is on our website under our knowledge base. So from the Cloud Router overview menu, select Add a Connection, select AWS, then you're going to want to choose your on-ramp. Here, you're just going to be able to see all of your available global on-ramps with AWS. For this demo, I'm going to choose Santa Clara. And then you're going to want to choose your speed. We do support up to 100 gigabits of line rate. We also support availability zones and public pairing, but we're not going to use public pairing today. You want to enter in your AWS account ID that we'll be using for the connection. This is where we can direct a connection to the account on your behalf. You'll add a description and then place your order, and in a short time later, it will be provisioned. We do need to accept the connection in AWS. So logging into the AWS console, you're going to want to select your connection and press accept in the top right corner. We then need to, once it's available, create a transit virtual interface. You're going to want to enter in all your information on the screen right here. And just note in particular the ASN. Now that you've created your transit virtual interface, you'll be able to access the BGP information, which is highlighted in a moment right there. Also note the ASN as we will need it on the Packet Fabric side. So copying the highlighted information from AWS, you can then select allow longer prefixes. This is going to simplify our routes. We're going to say anything to and from the cloud starting with 10 will be allowed, and then you're just going to want to submit that, and it is that simple. So our BGP session is going to be configured, and then we're going to go into fetching and potentially, and then ultimately it's going to end in established, which means we have routes. So now going back to our topology, AWS now looks like this, and we should see a 1088 route. And we're going to go to Google now. So for Google, we're going to create a partner VLAN attachment using the following information. And then we're going to need to get the parent key and the VLAN attachment name, which are highlighted. In the Packet Fabric portal, in the overflow menu, add a connection, press Google. And then you're going to want to select your on-ramp and then choose your capacity, just like you did with AWS. Then you're going to enter in your key, your parent key, and the VLAN attachment name from Google, and give it a description and place your order. And a short time later, it will be provisioned. So returning to the Google portal, we will then need to configure BGP, update the ASN numbers, as well as tell it to use the default, which is a cloud router and the advertised routes, and then press save and continue. We can then go back to the Packet Fabric portal, enter the highlighted information from the Google portal, and then enter our route filters, and that's it. And pretty soon it should be established. There it is. So now we have Google and AWS connections. Let's set up Azure. First, we need to create an express route. From here, we're going to enter in all of the information that is shown on the screen, especially the highlighted fields. Once we create that, then we can get the service key. This is going to be needed in the Packet Fabric portal. And now you go back to the Packet Fabric portal, go to the overflow menu, select Azure, very similar to AWS and Google, select your on-ramp, and then the capacity. You're going to want to enter in the service key, and you can add a description and place order. So just like the others, it will go into connecting and then established. So now I'm gonna show you how now I'm going to show you a different way to access some of your cloud router details. We will see each connections below. For Azure, we will view details, and then we'll need the VLAN in the BGP settings shown highlighted here. Then we'll enter our ASN, choose 2 subnets, and then the VLAN ID from our portal. From the Packet Fabric, back to the Packet Fabric portal, we will use the IP addresses that we entered into Azure for the connection, and then we'll enter our route filters and then submit. Then it should move from configuring to established. We do need to add a connection between the express route and our VPC gateway. So go into express route, choose connection, fill in the information, choose our gateway, and then we can set up previously after the validation and press connect. Create, apologies. Finally, back to our topology, Azure is done, and now it is time for IBM. From the Cloud Router Overflow menu, very similar, you just select IBM, you want to choose your on-ramp and capacity. You want to enter in your IBM account ID, which we have blurred out in ours, and then add a description. And you'll place your order. With IBM connections, we do need to go to their portal to accept it before we can proceed. So go into the interconnectivity, direct link search for your cloud router by name. You're going to want to scroll down to review the information and accept it. Choose your resource group, fill in the various options that work for you, and agree and create. Now the connection will proceed. Now to configure BGP, you'll note that some of the information has already been filled in by by IBM Packet Fabric API. So you're going to want to add in our route filters, and then you're going to want to press submit. It should now go from configuring to fetching to established. And now that we're done with IBM, we are all done with our topology. And as you can see, this is an extreme example of our vendor neutral cloud architecture that we've enabled. And with that, Alex, I'm going to bring it back to you.
Great, thanks. Yeah, so, I think a couple of points here just to highlight is that everything you saw there was something that you could do basically as if it's just software, but what you're actually getting are private direct connect type connections. In this case, to 4 different cloud providers. It is like you said, it is kind of an extreme example, but it just shows the flexibility and how easy it is ultimately. Obviously, you may or may not be, technical enough to do all the particular configuration, but for someone who knows anything about networking, and is used to creating these kind of network connections generally, this is very fast. It doesn't require any hardware at all, basically, for you to do this through hosted connections. So it's just extremely flexible and fast way to connect multiple cloud providers together. So with that, I think we're going to, at this point, go into some Q&A, but just before we do, just want to highlight that, you can go to, if you want to learn more about Packet Fabric and sort of how we do things and what is possible, you can go to our website, packetfabric.com. You can, obviously, there's lots of materials there. You can request a demo. You can actually register an account and just start going. There's also, you can contact us at sales@packetfabric.com. And, so there's lots of resources there for you to, kind of play with. So with that, I think we'll look at some questions. So I'm going to stop sharing. I think we have one question. I'm just looking over here about Cloud Router that we just showed, and why, how is this different from other cloud routers? That's sort of paraphrasing a bit. One thing that is really different. So first of all, there are products from cloud providers that use the term cloud router. The thing that's different or sort of limited about those is typically they will only allow you to have a private connection to them, and everything else is just like a VPN tunnel. So it's really you're not able to use the cloud provider specific cloud routers to get private kind of SLA supported connectivity to other cloud providers, just to theirs. So that's one thing to keep in mind, is just not to be confused or thrown off by that. There is some other offering in the market that tends to, but the really limiting factor about cloud router architectures generally is that they have one place that's running the cloud router. So if you have a lot of connections distributed geographically, for example, you have to route all the traffic through that one place. So for example, let's say if you have, connections that, let's just say, for example, in different regions of the US. But the cloud router instance is spun up in, Northern Virginia. All the traffic has to go through Northern Virginia to go to anywhere else. And that's not a very efficient routing. So it creates more latency. And as well, what it means is that with one sort of routing instance, cloud router capabilities, sort of in other offerings are very limited. They can only handle a few, maybe up to 5 gigabits per second bidirectional, or kind of like traffic. And so that's very limiting. So if you have low bandwidth needs, then those might fit the bill. What we have is, because our computing is totally distributed across our backbone, we have optimized routing, and we can support. So, for example, if you have cloud on-ramp connections in multiple places in the US or elsewhere, we're going to route optimally across our backbone network, that 50 terabit backbone network, between those on-ramps. So you're going to get the optimal routing. The other thing is that because of the compute scalability of our model, it scales up to 100 gig in terms of bidirectional throughput. So you can really drive a high degree of bandwidth demand through a cloud router. So that's something that's quite different about our cloud router compared to other offerings. I guess one of the other questions is just generally speaking on pricing, and maybe Kaz, maybe you could just give some orientation on like where folks can find more pricing information generally.
Yeah, so all of our pricing is on our website. We do, if you have a particular configuration in mind, we do say you could reach out to us at sales@PacketFabric, and then we can actually provide a quote that way. It's a lot easier if you have the data centers in mind and everything. And we do have our locations on our website as well, if you want to double check that we're in the same locations. And again, if we're not in an area or location you need, you can reach out to us and we can look into that for you.
Yeah. I guess one other question that comes up is between this notion of hosted and dedicated cloud connections. What was demonstrated in the cloud router demo was hosted connections, and those are ones where you don't need to do really anything except sort of a provisioning process. But dedicated just means that the port, let's say, to AWS that we provision on your behalf is dedicated to you, that all the bandwidth to that port is yours to use. It's sort of like if you were going to do a direct connect yourself to AWS, that's how it would work. You'd have to you get a 10 gig port and that's all yours. The reason why, a lot of customers will turn to us, not just for hosted, but also for dedicated connectivity is, one, is convenient to be able to just provision all through one portal, right? Not have to go to multiple vendors, have to have multiple sort of vendor governance and deal with terms in different places. It simplifies sort of like the way you provision and the language even that's used in a sense. We give a lot of guidance and make it very easy. The other is that in some cases where, you can use a kind of a provider like PacketFabric to provide resilient connections, different on-ramps or availability zones. So it provides, again, that sort of flexibility that you want and need. I guess one other question is coming from a partner point of view, what's the advantage to offering PacketFabric versus traditional telecom services? Obviously telecom providers have been around forever. They're, known, they're trusted. One is just to look at the kind of company, first of all, just to understand the company that you keep when you do business with PacketFabric is, if you look at our website, we have, major digital and other providers and major brands, like Zoom and LA Times and others. We have, I can tell you that without naming names, we have some of the biggest retailers with some of the biggest organizations in media and entertainment. We have financial, providers. We have a pretty wide swath of different types of enterprises, and from very large enterprises to, small and medium-sized digital providers, fintech providers, all that sort of thing. So we have a broad swath of customers. And, second thing is that it is, one of the major advantages is that you get a very full portfolio of services. So we built our backbone to provide not just cloud on-ramps, but to be able to provide, long haul, data center interconnect, at scale. So if you have a need for scale, all of our POPs are built with multi-hundred gigabit capabilities, just ready to go. That's why we have such a big backbone. So if you have a customer who has scalable sort of needs for bandwidth and has a need for cloud connectivity as well, data center and interconnectivity, we're really positioned kind of in the sweet spot of being able to offer that performance at scale. The third thing, just generally in terms of versus telecom providers, is that it happens so quickly. So if you have a project, the network no longer is a bottleneck to getting that project going. So if you need the network to come up fast to be able to move a project along, that does two things. For the customer, it just gets them to their goal faster and provides a much more satisfying outcome for them. For if you're a partner, what that does is accelerate your time to revenue, allows you to kind of deliver that business and be able to grow your business faster. So those are some thoughts in terms of why partner with Packet Fabric. And I think there was another question that I'll just touch on again, which is just why use Packet Fabric versus going directly to AWS. I sort of answered it before, but I think the thing to just think about is that one portal, one interface allows you to flexibly manage a variety of different sort of provision services. And we just give you that flexibility, the sort of a software sort of experience of it. And it just, I think it's so much faster and more agile and flexible than pretty much most other sort of ways of getting this interconnection, that it just makes it much easier to manage the network side of a project or of an IT infrastructure. So that's, I think that's the reason why there. So I think that's pretty much most of our questions. So with that, just want to thanks, Kaz, for the demo. Appreciate that. And thanks everyone for your time. Really appreciate your time and attention today. Again, if you have questions, you want to reach out to us, packetfabric.com or sales@packetfabric.com. And so thanks a lot. Appreciate your time.
All right, that's going to do it for our webinar. Our thanks to Packet Fabric's Chief Marketing Officer, Alex Enthorg-Iwani, and Content Manager, Kezia Lawson-Shanks. Thank you very much, both of you. And now from all of us at Channel Vision Magazine, from Alex, Kezia, and our friends at Packet Fabric, thanks for attending. Have a safe and prosperous day.
Bye all.